Hey everybody, this is Alex Merced and welcome to another Learning Python module. And basically what I want to go into today is collections, basically talking about how you can collect multiple points of data into a variable. So what we're going to do is create another file. Again, all of these files you can find in the repo that's linked to in the video description. So I'm going to create a new file. Again, we're going to create a new Python 3 kernel. Okay. Cool. I am going to rename it. And I'm going to rename it collections. Okay, and essentially a collection is a way to store multiple pieces of data into one variable. Okay, like the first one, pretty straightforward, is a list. Okay, which is just basically an ordered list of items that can be changed. So you can manipulate this list. Okay, and basically creating the list is pretty easy. You just make a variable, my list, and it's going to be the square brackets that denote the list. So if I were to make a list of numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then square brackets to sort of end the list. Okay, so bottom line is if I were to print the list, we'll see the full list. Okay, so again, here I'm printing the full list. But I also can print an individual item on the list using an index. So I can do something like this, like list, then you put square brackets after the name of the list, and then you can say which item you want, starting with 0. So always the first item is 0, then 1, then 2. So if I want the third item, I would print out index 2. Okay, and this would print out the third item. Why? Because we have 0-based indexing. Now, why is that? Well, the reason is because this is based on sort of the way arrays work when you get to like C and C++. Essentially, what happens is really a list like this is like each value really takes up a place in memory. So oftentimes a old school array would essentially be a sequential block of memory. So you'd have enough memory for 9. So if you created a 9-number array, you would get enough memory for 9 numbers. So essentially the index told you how many steps away from the beginning would you find the number you're looking for. So the first thing would be 0 steps away from the beginning, and the second thing would be 1 step away from the beginning, and 2 steps away from the beginning, and so forth. So that's where the 0 numbering comes from. Now it's just sort of part and part of being a developer. It's just sort of the way we think. So that's just where that comes from. Now I print out the third item, and now let's actually run this. Okay, and you see that when I print out the list, I get this object of class list, and here I get list 2. Oh, because I wrote list, not my list. I was like, wait a second, that's not what I expected. My list. You're probably watching thinking like, Alex, I saw your mistake a while ago. Oh no. Okay, let's try that again. Okay, and so you can see that when I printed out my list, it is the full list, and then when I printed out a single item, it in fact was the third item. Now I can add items to my list, so I can just say, hey, my list dot append. Okay, and I can just say, hey, I want to append the number 10 to the list. Okay, and then I can, oops, I go back to that. I want to print. I want to print the list again, my list. And then when we run that, see now my list has 10, even though it added it twice because I ran it twice, that's why. Okay, and I get a maintain state. So that's what happened there. Okay, but if I ran this from the beginning, okay. Okay. There we go. Perfect. Okay, and then what I can do is I can also remove things from the list. So I can say, hey, my list dot pop, and let's say I want to remove this, the fourth thing from the list. Okay, I can specify an index to remove. So I can say, hey, I want to remove the number 6, which would be index 5. Okay, and then if I were to print my list, there you go, 6. So list pop returns whatever it removed. So what it removed was 6. So if I were to print my list, see my list doesn't have 6 in it anymore. And that's something to kind of keep in mind that I haven't really talked about yet, is that the certain functions actually give you something back. So in this case, whenever we hit a line we run a cell, we're going to see any prints and any returned values. So in this case, since I didn't print here, but the pop function does return a value, we do see that value as the output. So okay, so just keep that in mind. And generally, I can actually use that output in different ways. Gonna step that to the side for now until we actually start seeing some examples of us using it that way. But just aside, just know that certain functions give you something back. They return a value. So that's a list. Okay, so oftentimes you'll use them a lot for like list of numbers. Now the thing is that lists under the hood are implemented as what's called a linked list. So, which gives it a lot of flexibility, but not necessarily the most performant thing, because you have all these scattered bits of memory that are all referring to each other. And that's how it's able to kind of create this dynamic size. So what happened is that there is a library called NumPy that implemented sort of more structured, more static arrays in Python, okay, which is much faster. Okay, generally you're using arrays that all have to be the same type of value, which means it can. And the thing is that generally the more strict and the more defined a data structure is, the more efficient it can be about how it uses memory space, because it doesn't have to plan for as many scenarios. So a much more efficient data structure is going to end up being a much more fast data structure. So the arrays in NumPy are generally faster, which is why things like pandas and polars and other libraries generally use those NumPy arrays for when they make lists of numbers and things like that. Okay, so just a little background there on understanding sort of Python and performance and things like that, because Python can be extended using C and C++, using something called Cython, where you can actually write C to extend the functionality of Python. So you can create like new data structures like these NumPy arrays. I'll talk about NumPy later on once we kind of gone over all the core Python stuff. Okay, next collection. Next collection we want to talk about is a dictionary. A dictionary is just a key value pair. Key value pairs. So essentially, if I want to create a dictionary, so we'll say here, my dictionary equals, and here we use curly brackets, but then we provide a key, which is like a label for something in the dictionary. So kind of like in a dictionary, you look up a word and you find a definition. Here we look up a key and find a value. So in this case, we'll say, hey, name is Alex Merced. That's my first key value pair. Then I can add another one using a comma and say, hey, age, colon, 38. Okay, and then there's my dictionary. Okay. And now what I can do is I can print the dictionary. So print my dictionary. And I can print a single item for my dictionary. So I can be like my dictionary. And once again, we'd use the square brackets. But instead of passing a number, what you do is you pass a key. So I would pass the key of name. I want to print the name property from the dictionary. So again, this here, what I'm doing is I'm printing the entire dictionary. Here I'm printing one value from the dictionary. So if I run that, okay, you can see that I print out the full dictionary on one line, just a single value of that dictionary on another line. It becomes a nice way to kind of package lots of data that you may want to refer to. Okay. And then there is going to be the tuple, which is also a list of things. The only difference is that it cannot change. Okay, so a list of data that never changes. So once you create it, you can't change it. Okay, this is generally, the beauty of it is that tuples under the hood, if you know you can't change it, it doesn't have to like be set up in a dynamic way to prepare for adding and subtracting things. So again, it can make more efficient use of memory. So generally, if you know you're going to get like a list of 3 numbers every time, why use a list, which is less efficient than using a tuple? You'll get a little bit more performance. Again, the way I would think about it is in the beginning, if you're just learning Python, you should be able to do 90% what you need to do just with lists and dictionaries. And then once you get really comfortable with lists and dictionaries, then start adding like tuples and sets, which we're going over now. Because right now you just want to think about sort of like, how do I use the code that I'm writing? And then you start thinking about, okay, hey, which tool is going to be best for a particular situation? But first, just get used to using the tools in the first place. But essentially a tuple, the way it works is you would just say my tuple. Just like an array, you would just define a list of items, except you use parentheses. So it would be like 1, 2, 3. Okay. And then if I were to print my tuple, I can do that. I could also print a single item for my tuple, which is just like a list. So I should be able to just do, let's say the first item, 0. And it works. But again, the idea here is I cannot add or subtract. That's a fix. Once I create it, it's fixed. Okay. Again, it has its usage. Oftentimes when you're pulling in data and you know that the data all has the same number of items and never changes, use tuples. Okay. And then one more are sets, which is all another list of items with no duplicates. Okay. So once again, you can put a list. So I can say, hey, my set equals, only difference is now I'm going to use curly brackets, but instead of doing key value pairs like the dictionary, I put numbers. So I can do like 1, 2, 3, 4, 5, 6. But what if I did put duplicates? What if I put a bunch of 6s in there and then a bunch of 7s? What do I end up with? Okay, so then we'll print my set, and then we'll try printing an individual value. Print my set square bracket. Those print the second item, so that'd be 1. Okay, and then if I run that, okay, now again a set. So we got this error because these sets, even though they are a list of items, okay, and see I removed the duplicates. Nice. It is not a subscriptable item, just meaning you can't pull out an individual item. So oftentimes what you would do is you would take a set and turn it back into an array. So it's useful for like taking a list of numbers or a list of things with duplicates and deduping it. But you probably want to convert it back into actually a list afterwards. So in that case, what I could do, let's give it a shot. If I use the list function, I can convert that set to a list, and that should be able to access the first item. So let's try that out. Make sure it works. Okay, name list is not defined. Let me think about that. Boo, it's a function. It's lowercase. Blah. You can tell it's the end of the year. Okay, list. So now that should do it. Let's try that again. And there you go. So see, I can convert that back to a list. That's what I did here by using that list function that just took the set and turned it back into a list. And then I can access the second item in that list. So that's an alternative that you can do. But again, sets are really just for the purpose of taking something and kind of removing the duplicates out of it. So you can get a list of unique items. But you probably would want to convert it back into a tuple or a list depending on what you're trying to do. And yeah, so those are the 4 types of collections. So when you think about, hey, I need to store multiple pieces of information, these are generally going to be the containers that you'll use to do that. That are built into Python. Again, I mentioned earlier that there's things like the NumPy arrays, newer things in Python like records, which I'll cover, that offer you some more efficient ways when performance is a thing. So we'll talk more about that later. I'll see you all later.